So good afternoon, everyone, and welcome to the session on creativity, innovation, and inventive problem solving. So before we go into today's agenda, let me just quickly catch up with all of you on how are things coming along with you. Are you attending office hours? Are you facing any challenges? How are things with you? How is the project coming along? Please, if you have any concerns about what we discussed in the last class, are things clear? What is happening?
Hello, sir. Good afternoon.
Good afternoon.
Actually, sir, whatever solution that I am thinking or I am trying to do, it already exists in market. So, should I proceed with my idea or should I change it? I have tried 5 solutions till now. I have think of uh, think of that, and all that 5 solution already exist. So what should I do now?
Yeah. So Anuj, dekho, at any point of time, there will be some solution that would exist in the market.
Yes.
That is where things were working. But each of those solutions would have some problem, some limitation.
Mm-hmm.
So you select which problem you really liked, and you pick up one target solution also, let us say. Okay.
Okay.
And then start to apply the tools like do the function modeling, see where is the weakness. Then, as we will start in tomorrow's class, we will start with the solution finding space. See, till now, we are in the stage of problem identification.
Yes.
We are trying to reformat the problem, look at it from this perspective, that perspective, so on, different perspectives to see is there a cheaper problem to solve. See, the problem at hand could appear to be very complex. We don't want to enter into that complex a problem right away. We are just looking at it from different perspectives to see if I can define a simpler problem. So from tomorrow onwards, we'll enter into solution finding stage. I am assuming that after spending so much time on the problem statement, you have sufficient understanding of the problem statement now. And now we enter into solution finding stage. So I assume you have made the function models, you've done all that. So pick up the problem that excites you most, make the function model of it. And then when we start to look at, say, technical contradiction matrix, or find the solutions to the existing limitations in your system, that is where the inventive steps would come in. So obviously some solution exists. That is why things are still working. Otherwise, someone else would have raised a big flag and crisis mode mein kuch na kuch, so something would have been worked out. Things are working. Things are working. It means some solution exists somewhere. We need to
Yes.
improvise it. That is where inventive steps would come in.
Okay, sir.
Okay. So you attempted 5 problems. Very good. Now you are now having seen 5 problems. Which one excites you the most? Which one do you think is the most promising one? Pursue it like that.
Okay, sir. Okay. Thank you, sir.
Yeah. So anything else from the last class that we were discussing which you would want to ask, or any questions? So what were we doing in the last class? What did we do in the last class?
So basically, we studied some more methods so as to how to zero down a problem. So like 9 screens method, we saw feature transfer thing and these so various techniques through which we can zero down a problem.
Yeah. What is this 9 screens method? Why is it interesting?
So basically, we are splitting a problem into 9 screens. So we are talking about the future aspect and also the past aspect of it. So and where various other super and sub components involved in it. So basically, when we split into 9 screens, we can easily think of how is our problem working, how is it exactly, what would be its future, and what exactly are pretty existing solutions, and also we can think various ways on it.
So by looking at the 9 screens, you can anticipate how the problem would evolve, how things can move, and then you do something about it. Great. So you again, 9 screens is also a part of the problem identification stage. That okay, is the problem at interesting to solve at the super system level, or the system level, or the microsystem level? That is what 9 screen helps us to do. Okay. So today we are going to look at flow analysis. Yes, Soumyadeep?
Sir, isn't ninth screen basically targeting the solution?
No.
But in the last class, like you were saying that we need to, like in the ninth screen, one screen was future system, and you said that we need to, basically the future system would come from the weaknesses of our idea, and so we need to find the weaknesses of our idea and implement those right now.
Yeah, so you identify the weakness of your existing system, na? So that is the problem. That weakness is the problem, na? That you solve it. See, you know the final goal. In the 9 screens, you get to see the final goal. You do not yet know the way to that final goal.
Okay.
Are you able to see this final goal to dikh raha hai, but how to approach that? There are some blocking points. That is where the solution finding tools will come into picture. 9 screens is simply telling you, this is my goal. This is where I am today. So this is the problem. Going from here to there.
Okay. So basically the future system is our solution that we will try to reach. Or we will
That is
try
the
to-
objective. That is the target.
Okay.
Yes. That is the objective that we want to accomplish. But how to do that comes through, okay, to be able to move from here to here, I need 2 inventive steps. Which ones? That is what I call as solution finding stage. अभी तो आपने target identify करा है.
Okay. And current system is current alternatives or competitors.
Yeah.
Oh, okay. I had a misconception. Okay. Thank you.
Okay. So I know that many of you are also working on flows. Flows means processes. That okay, there is you're not really working on a product. You're not saying that I'm going to create a cell phone or a mirror or a smart curtain or anything like that. What you are saying is, I want to provide a service. So I want to go do this additional service. I want to do that additional service. At any other places, at any other point of time also, you realize that there are processes that are put in place. Like there is a process to deposit your college fee. You need to go to a particular portal, you need to select something, then you need to do something else, and you need to do something else. Finally, you make the payment, and then you may need to send an acknowledgement or a receipt to someone so that it is registered. They will send you back an acknowledgement that, okay, we have recorded your fee deposit, and so on. So there is a process flow. There are multiple steps in this process flow. Things that you are working on are also kind of, many business models are essentially about process flow. For example, that home kitchen thing, for hostel students, example ke taur pe de rahe hain. So what happens there? You need to define a process flow. When will the student place a request? What will happen to that request? When will the request go to the kitchen? What will the kitchen do? And then after the kitchen has done that, who takes the food from the kitchen to the hostel, and so on. So there are these multiple steps involved. There's a flow involved. And how you manage this flow will finally define your profitability. So someone could do it. Someone would say that, okay, you order grocery, and when you order grocery, I will deliver it to you in, let us say, 4 hours. Amazon Fresh says, you order grocery, I will deliver it to you in 24 hours. Blinkit says, or Swiggy Instamart says, you order grocery and I will deliver it to you in 10 minutes. Same work is happening in all the 3 places. But the efficiency of the processes and the cost of the processes is very different. And the kind of market each would capture will also be very different. Are you able to see this?
Yes, sir.
So innovation, for example, Blinkit did innovation in the delivery system where all of a sudden, I'm not sure if you guys noticed or not, all of a sudden from 8 to 24-hour delivery, they shifted to almost 10 minutes delivery for most of, say, NCR region. Have you experienced this? Those of you who are in NCR or at least tier 1 cities?
Yes, sir. Especially
How
the
did it happen?
September.
Yeah, how did it happen? So basically, they must have done is they must have looked at their process, they must have modeled it somewhere, and then they must have improved it. Many of your systems that you are, or many of the things that you guys are also talking about. For example, there is a group talking about putting EV charging stations. So there is a process of that. How would a customer come to know that there is a charging station 500 meters ahead? Or how would you charge the customer? What will the customer do when he or she, when they reach the charging station? What do they need to do? Do they need to simply plug and play your socket and stuff like that? Or do they need to first scan a QR code, get an OTP, then do something, What is it? Because you need to ensure security, you need to ensure money has been paid, you need to ensure so many things. So what is it that the customer has to do to get the activity completed? That is a process flow. So many of your ideas, you are working on process flows. So today what we are going to look at is how to model the process flows. So in the previous section, when we did function modeling, we did function modeling of products. Today we are going to do function modeling of processes and trimming on processes. So for a lot of your projects, what we are going to do now will be very helpful. Some of you may be collating data, some of you may be doing, whatever you're doing, there is a process involved. So how to improvise the process so that either your profitability improves or a key performance index, a parameter of importance, a main parameter of value improves, something significantly changes so that your product stands out. Your service stands out and people want to associate with you, not with your competitor. So here we go. As I said, this is also a part of problem identification schemes. So we have done in the problem identification scope, we have done feature transfer. We have done 9 screens. We have done trace benchmarking, function analysis. We've done cause effect chain analysis. We've done trimming. So today, now we are going to look at flow analysis. And with that flow analysis, we will also look at trimming of the flows. So if you go by what we were talking about how we looked at function modeling of products, how do you think function modeling of flows would be done? What are the key things that function modeling of flows would require, according to you?
Identifying all the subsystem components who are interacting in the flow.
Identifying all the subsystem components that are interacting in the flow. So think of a flow. Think of a flow of your fee deposition. All of you deposit fee. Think of that flow for now. What happens there? What happens there when you deposit a fee? How will you make a flowchart of fee deposit mechanism?
Like first login by student, and then after that entering the amount of fee, and after that submitting it via any platform like card or UPI payment or NEFT. And that's it. And after that, receipt generation.
So we
After that,
also,
yeah.
So we also choose which branch or which, like the type of student we are, bachelor's or master's, and automatically at the back end there it's fed like how much fees we have to give. So once we select or once we provide our roll number, they give us the whole breakup and then we pay accordingly.
Okay. So what are these? Are these interactions between components or what is happening here? Are you really interested in components or the steps? Interaction between steps, handshakes between steps.
Can we say that like the components are being replaced by processes and the interactions are being replaced by flow between those processes, something like that?
Yes. So look at it also like this. While we as software engineers and as electronics engineers would be thinking of stuff in terms of movement of information, when Altshuler studied these patents and everything, at that point of time, information was not as much a in thing. What was more in thing was something like what you would call as fluid mechanics. And Altshuler therefore initiated or added this technology or this thing of flow analysis inspired from the concept of fluid mechanics. So we will see just now that different boxes that you would have in your flow chart could be considered as different pipes, and the bandwidth or the throughput of these pipes could be considered as a diameter of these boxes, or these steps could be considered as the diameter of these pipes, and so on. Okay, so what function analysis for products we did over here, when we say that we're doing function analysis for processes, we are saying that we now identify functions instead of components. And a process is a sequence of actions or functions on material objects. A technological process is a process that uses material objects, such as, now over here we have added, as time has evolved, we have added stuff like information, data also into it. But when Altshuler did it, information might have still been there, but data definitely was not there. Energy, labor, material, all those things were there, but these are what were added much later as say computing paradigms evolved. Okay. So what we do over here is we want to build a model which includes functional contribution of each operation. Okay, you wanted to log in. What is the importance of this login? And the corresponding costs. That to ensure your login, I have to maintain a server that does this, or this is the load of the server that is consistently and continuously given to the login process. So that kind of stuff. So you corresponding cost, function type, is it critical, is it not critical? We will just look at different function types, and performance. Just like for functions and product modeling, product function analysis, we saw the performance. Over here also there is a concept of performance. But yes, we're talking about functions, and a series of functions is what is being called as a process. And we rank the functions also, just like we do in product modeling, and that information is used for trimming. Okay. The outcome of function analysis of processes is a function model, which also lists down functional disadvantages, so that in the subsequent stages of analysis, those disadvantages can be removed. So it is a kind of parallel of product analysis, but you will see it handling changes a bit, and therefore you may find applying flow models on your algorithmic problems much faster, much more convenient than the function modeling that we did earlier. Okay, let's take an example. Let's take the example of reheat and blow process. What is reheat and blow process? Can anyone tell? So those of you who drink Coke, Pepsi, all that, you see the bottles there. So those bottles are actually made out of these pellets. And these pellets are plastic pellets, which are put into a mold. Like over here, the plastic pellets, they are put into a system, they are heated, then put into a mold and molded according to the shape of what you want, according to the shape that you so desire. So RBM process involves injection molding, where plastic pellets are plasticized and put into a molding machine, melted, heated, and then pushed forward. Once that happens, once the liquid plastic is available, you create preforms. So even if the 1 liter bottle would be this tall, the preheat forms you will notice are just this small. The preforms are much smaller. You transport the preforms from one place, from where you made the preforms, into another place. You organize them. For example, you put them in a kind of a belt or something like that, so that they are more controlled. And then once that is done, you put those small preforms into an injection mold and blow heated air into it. As more and more air goes, the preform expands gradually and finally takes the shape of the finished bottle. Okay. After the shape is there, then you cool the bottle, and then the bottle, you will notice, may have small rough corners or something here and there. From wherever your mold had a little gap, some plastic would enter in that place also, and there could be some such stuff. So that part is removed. That part is trimmed. That seeps through the mold during manufacturing. That part is trimmed. Now, are you able to understand the process? Any questions about the process? Are you able to visualize it? Okay. So now this is the way bottles are made. But there is a problem. What is the problem? The problem is that if temperature, if the plastic is heated beyond about 115 degrees C and then quickly cooled, then what happens? There is whitening of the bottle, and the bottle does not look to be good. See, the bottles that you see coming to your homes, they do not have any whitening of plastic happening anywhere. They're all transparent. Why? Because the color of Fanta or Maaza or whatever it is that you're drinking, that should stand out, that should come out, and people should be able to purchase the bottle getting excited by that color, if nothing else. So that haze and stress whitening is something which is not desired. And one thing also that we see is that this trimming part that we talked about, this trimming part, this takes time. You have to remove all these extra plastic that has seeped through to give the bottle the shape that it really was intended to take. So this is something which is costly. A costly process, doesn't really add much value. So this also needs to be removed. So now we start to do function analysis of the system. So is the problem statement clear? Okay. So now we start to do the function analysis of the system. So what does function analysis entail? Function analysis, again, we start with what is called as component analysis. Over here, components are operations. Operations where we say that a component, you list down what all operations are happening, different functions that are happening, and and then you kind of, in the function modeling stage, you connect them. Let us look at the same example, and let us look at how this would be modeled. So first thing is, there are different kinds of functions here also. Useful functions, harmful functions. No further classification of harmful functions, but useful functions are divided into, or there are three types of useful functions: productive, providing, and corrective. There are three types of providing functions: supporting, transport, and measurement. Each of these functions, each of these operations has a cost associated with them, and a value that they add to the system. So this we already saw. The productive functions are useful functions that bring about irreversible changes in a product's parameters. For example, to form a helmet, or injection molding through which the shape of the bottle is the bottle is given its shape. So the litmus test for productive functions is that whatever change they brought about should be evident and available in the end product. That change should be evident and available in the end product. And some parameters should have been changed. Some parameters are changed irreversibly so that they are also visible in the product. That is what is called as a productive function. Providing functions are again useful functions that help perform other useful functions. For example, transport. Now, moving food from the kitchen to the hostel, does it add value to the food?
No, sir.
No.
No,
But
sir.
it ensures that a process of the food that the kitchen had prepared is now available to the end customer. So it is ensuring that things move smoothly. Measuring the food. Okay, I'm putting 2 or 500 milligrams or 500 grams of something. That doesn't add value to the food, but it's an important step because that is the only basis on which I will get paid. Supporting functions. So let us look at the details of providing functions there. So supporting functions are providing functions that temporarily change parameters of a product. For example, to bend a metal rod, a lot of force is needed, but if you heat the metal rod, it can be bent with much less force. In this case, bending the rod is a productive function because the rod would appear as bent after the operation, after the activity has been completed. But applying heat to the rod is a supporting function. Are you able to see this? So
Yes, sir.
supporting functions bring about a temporary change in the parameters of a product so that other functions can happen much easier at a lower cost. Okay, they are like catalysts. Then transport functions, it's as the name suggests, it is moving material from one place to another, changing their coordinates. Except, for example, if you say that you are a logistics partner. Logistic partners means you are a partner whose entire job is to move material from one place to another. Then it is no longer a supporting function. It is no longer a providing function. Then that transport function in itself becomes a productive function. So moving material. So we were talking about steel ball bearings. They were moving from one part of the shaft floor to the other. That movement was a transport function. So it was a providing function. The belts, the conveyor belts in various factory shop floors, they're also only doing providing function. Now this food delivery thing, if it is such that, if we talk of Zomato, so why do I hire Zomato? Because I know that, okay, first it will provide my order to them, give my order to them, and then it will deliver the product to me. So that movement or the change in coordinates of the object is what is most desired. That is the reason why I took that service up. In that case, that transport function is not called a transport function, but it becomes a productive function. A courier person, that is a productive function. Uber, transport is not a providing function there. For Uber, transport of cargo or men or passengers is a productive function because that is the main objective for which the system existed. Okay. Third type of providing function is measurement function, where we kind of measure some parameters of the material objects. For example, thermometer informs a worker about temperature of the product. So measurement functions are also there in every system. You want to bring some order some grocery, so the grocery has to be measured and the stuff has to be then delivered to your home. So measurement function is there. Then there are corrective functions. They are useful functions that are directed at a defect. What is a defect? A defect is a substance or field object that impairs performance of a useful function or performs a harmful function. Okay. For example, the bottle that we talked about, the polishing of the bottle so that these extra plastic that had got formed, this polishing is a corrective function. So over here also they are showing some polishing so that defects related to welding joints can be corrected. So these are corrective functions. Now, just like for products, we make a table for function models of for modeling the processes also. We can use the legend productive, providing, details of providing function, measurement, supporting, transport, or corrective. Okay. So if you look at the blow method or the bottle manufacturing process, we look at, okay, injection molding. What is the function? Plastic pellets plasticized. Is it a useful function? Yes. Type is productive. Level of performance, normal. Cost, very high. Okay. Now, creation of preforms, plastic injected into parissons. Useful function again. But now it is a providing function, because at the end of the entire process, you do not see those small preforms. You see a finally built up bottle. So this is a providing function, but a supporting one. It helps to build the final bottle from these parissons. Okay. Then moving these parissons to the bottling site, that is transport, orienting them, unscrambling the parissons, putting them in such a way that every lid kind of is facing up. That is again a providing function. And then the blow and stretch process, that is a productive function. Cooling again is a productive function, because after cooling, when this product goes out of market, you notice that the temperature is room temperature or lower or whatever. So it is therefore a productive function. And then trimming, that is cleaning up this, is a corrective function. Okay. So now notice that there is an I placed here. Why do you think this is placed here? What was the problem that we were discussing? In bottle injection process flow, what was the problem that we were discussing, that we wanted to solve?
White marks, what we get.
Some haze that one would get in the plastic. So because that is happening, I call this as an insufficient level. We know that, okay, plastic के अंदर वो तब होगा जब cooling खराब होगी. When the cooling is not correct, that is when this haze happens. So that is where this function is happening insufficiently. Okay. The cost of this function is already low. It does not take too much. I'm just cooling, so it does not take much energy. ये तो scavenge कर रहा है. This is simply scavenging the heat from your system. So cost is low, fairly low, but it still is happening insufficiently. That is why that haze gets formed. So once we have this kind of a model, then we look at trimming, where we say, okay, which functions from over here can be removed so that the overall cost of the system, overall efficiency of the process improves significantly. So again, it is the important thing is that you redistribute useful functions of the operations amongst remaining operations. So you removed one step. Suppose you said that, okay, I've removed the step of login authentication from entering into ERP. When you want to enter into ERP, you can still enter. But when you want to save, so along with save, I then ask you to log in. So I moved the separate login step at the beginning of the process to somewhere in the middle, redistributed it to another place, but the useful function has been retained. Are you able to see this? Any questions?
Sir, in the previous slide, what did U and N stand for?
U stood for useful function, N stand for normal performance.
Okay.
Same terminology as, or same legend as product function model that we saw earlier.
Sir, I wanted to ask that in a process, like, will there be any non-useful functions as well? Like any step which is non-useful, like why will we have it if it's non-useful then?
Oh, you may have it simply because it is a byproduct of some other process.
Yes, sir. Yes, sir. Yes,
You
sir.
could still have it.
Okay. So like in the bottle process, like everything which we are doing willingly is going to be useful process, and something what we get as a byproduct, let's say, is something which is not useful.
Yeah. So बॉटलिंग वाला जो हमने बात करा उसके अंदर कोई वो नहीं है. There is no harmful function happening here, but there could be processes. For example, the bottle is heated, and it could happen that on a particular shaft floor, the way things are, the heated bottle does come in touch with some other fabric, some other material, and therefore that material gets either burnt or not really usable later. So there could be harmful functions also.
For sure, sir.
They might be unintended, but they just happen.
Okay, sir. Thank you, sir.
Okay.
Yes, sir. Thank you, sir.
Yeah. So when you want to now remove such functions, you need to do again follow a process. What you need to trim or which operations can be trimmed, you can again do from what we call as cause-effect chain analysis and value analysis. Operations for trimming can also be selected based on the types of functions that they perform, and the relative importance of operations is as below, in the sense that productive functions have highest rank, corrective functions have least rank, because they do not really add value. They just take a lot of time, polishing and everything. They just take a lot of time. They actually take some material also with them, but they do not really add much other value. So corrective functions are lowest rank. We do not want them to happen. We do not want to get bogged down by them. But then there are productive functions at the top, and amongst the providing function, supporting function, then transport function, then measurement function. Okay. So how do we do the trimming? An operation with a productive function can be trimmed if the object of the analyzed function is eliminated from a system, or the necessity to perform that analyzed function is eliminated altogether. Suppose measurement, you wanted to carry something until it cooled down to, let us say, 50 degrees Celsius. So, and as a first, the farmer or whoever it is will measure the temperature and ensure that it does not exceed 50 degree or go below 50 degree, whatever your constraints are. And you use some other material, let us say a ferromagnetic material with a Curie point of 50 degrees, such that as soon as that Curie point is reached, the magnetism is gone and your product falls back into the desired state. So you wanted 2 extra plates of paranthas, but by entering into eliminating the need of a function, you say, okay, with the query point thing, this thing is taken care of. We will see an example later also, don't worry. Okay. Or if the analyzed function is transferred to the preceding or subsequent operation. For example, the login in ERP, you allow everything for a student to put in all the courses there, but you ask them to log in only when they want to save, only when they want to submit their registration. So the login operation has been moved. The function login has been moved from the first function, from the first operation into a much later operation, and the user can actually start to work on your system right away without even logging in as a guest. So that was for the trimming the productive functions. Okay. Now the operation with a supporting function can be trimmed if the operation requiring the supporting function is itself trimmed, or it is changed. The operation is changed such that it does not require any additional support now. Operation performs the supporting function itself, or the analyzed supporting function is transferred to the preceding or subsequent operation. Similarly, there are rules for transport functions, where we say that the transport function is eliminated if the object of the function is eliminated. If there is no food to be delivered, what do you transport? So the transport function vanishes. The components between which the object of an analyzed function moves are eliminated from the system. So the source and destination of this transport, they are removed. So this function is no longer valid. It cannot work. Or the subsequent operations are changed in such a way that the necessity to perform the function is eliminated altogether. Or the analyzed function is transferred to the preceding or subsequent operation. Is this clear? Any questions on this until now? No questions? Okay. Then a measurement function can be trimmed if the operation is trimmed according to the conditions that exist in the productive function. A measurement function that is needed for providing another operation, if that operation is trimmed, then the supporting function is, then this particular function is also trimmed. So when the target is trimmed, or when you change the process in such a way, the flow in such a way, or whatever you're looking on the flow in such a way that those measurements are no longer required, it does not bother you. Okay, you can trim that function. Now, corrective functions can be trimmed if the operation that generated that defect is eliminated. Suppose I eliminate the process of heat and blow so that the bottle stretches. If I can do that and get some holidays, then if I can remove the defect generation in the first place, then this operation can be removed. Or the operation that generates the defect is changed such that it does not generate the defect any longer. Or the operation is changed in such a way that it starts generating defect with another set of parameters. Now, what does this mean? What do you think this means? Point C. What do you think point C means?
If for example, instead of the extra bumps other than the plastic, if if we change the problem and say that there were areas where the bump was less, for example, so you would have to do a different corrective function there.
Yeah, suppose you added some other vacuum process, or you change the mold design in such a way that those leaks in the mold are reduced, and they are reduced in such a way that now any bump is less than, say, 0.5 millimeter. So now it is within the specification. It doesn't bother the aesthetics of the design, and therefore you say, okay, now since it is within 5 millimeters, I know there are defects, but they are within 5 millimeters. They're not even visible to the naked eye. So let us not perform the corrective operation over here. Okay. Then operations which are harmed by a defect are changed in such a way that they become insensitive to it. For example, one of the functions or one of the operations that a bottle with those extra appendages or extra plastic would not work is, for example, this is the bottle, this is the intended design of the bottle. If there are these spikes of plastic here and there, what happens? The bottle can become unstable. But if you change the product or the process in such a way that the system becomes insensitive to the defect, in such a case, again, the need for the corrective function is eliminated. Okay, I know there is a problem there, but it does not impact my solution. It does not impact the service that I am offering. So I will not do the corrective function. Then when the corrective function is transferred from that operation to the operation producing the defect, or it is given as a separate, it is given as a separate activity to another preceding or subsequent operation. Okay. Now what you do after that is you put all these different operations into different buckets of cost versus functional significance. The ranking we just did. What is the functional significance? So we know that functional significance of injection molding and stretch blow molding is very high, but the cost is also very high. Now over here, the cost could be in terms of thermal budget. Not always money. So now what would you do here? Which, according to you, which function should be trimmed first? Hello? We've already seen. I'm sorry?
So the process that is involving low functionality and high cost.
So something in this quadrant, whatever falls in this quadrant should be removed from the system to maintain the longevity of the system. So if we look at the various activities, we see that trimming is the only activity which has high cost but low functional significance. So we try to eliminate trimming as the function which needs to be trimmed. And we say, okay, let us apply rule B such that the operation that generates the defect is changed in such a way that the defect is no longer generated. And if we want to remove the trimming part of it, so what would need to be done? We say that, okay, this trimming part is causing a problem, or something is not right because there are these extra woe. So you, instead of putting the parison in one particular way, you put the parison in a different way. And that part can be taken care of. You can make the mold in a different way so that this is taken care of. The problem of haze that was coming, that can be taken care of by saying that, okay, so initially there was this coolant which would go, and the mold cavity would be at a distance from it. Do you notice that there are some parts of the mold which are farther away and some parts which are which are closer to the coolant channel? Are you able to see this? These two distances are different from here.
Yes, sir.
Hello? Yeah. So they say that, okay, if I change the way the coolant pipe is made, then I do not need to split my process into two parts. So they looked at various types of mold making materials and the materials that were to be used and all that. And they could see that, okay, there is some benefit from this that can be done. We change the material and the extra trimming or the extra defects that were appearing can be reduced and so on. And as we just said, they changed the shape of the coolant pipe also to align with the mold so that overall costs are reduced. Questions? Because then I can actually take you to another example which could be closer home. Questions till now? Any questions till now? Okay. So now we do take another example, say cake making process. So cakes and pastries, these days people like, there are very small cakes also, big cakes also, one person cake and 5-person cake, and then huge cakes. So cakes, different events, occasions पे आजकल बहुत widely बुलाए जाते हैं, are purchased. But those of you who have baked the cakes know that the process of making a cake, the baking a cake, is a slow process. And there's a lot of wastage involved in making cakes. Because some shape would get deformed, you cannot really have a flat top at all times, and so on. So there is a kind of challenge in the cake making process, and which we want to take care of. We say that the productivity of the process is low because of the slow baking of the cake, and that shape giving thing comes into picture because there are defects like cracks that could appear in the cake. So just a quick diff check. Have any one of you baked cakes at home or something like that?
Yes, sir. I always.
Yes, sir.
Okay. So
Yes,
then you can actually relate to this thing very well. You must have already cut the top of this kind of a cake so that it becomes flat, and some part would be burnt out over here. You remove that, all that you would do. So to increase the product, so what do we want to do? We want to increase the productivity of the cake making process, and we also want to eliminate defects and uneven surfaces. So what are the operations involved in the cake making? So prepare the batter, fill the mold with batter, take it to the baking oven, getting it baked, and then removing the cake from the mold. After you remove it, there are these cracks that we saw which need to be removed, and then you decorate the cake so that it appears like a good cake, a bazari cake. So if we want to now label these functions, these operations, so preparation, what does preparation involve? Preparation involves measuring each ingredient and then mixing all ingredients. Measuring is a providing function, so measurement, whereas mixing all the ingredients is a productive function. Are you able to see the difference between the two?
yes, sir.
Then after that preparation is done, you do the filling. So for that, again, there are multiple steps. You first grease, then pour the batter. You first grease the mold and then you pour the batter. Greasing the mold is a providing function. Whereas pouring the batter into it is a productive function, because the shape that the batter takes at the end of this function is what will be visible or what will be evident even at the end of the process. So it becomes a productive function. Similarly, you list down all these functions. You notice there is one corrective function here, which is slice out the uneven surface of the cakes. Removing function is a transport function. Then baking is supporting function, and so on. So there are multiple functions here. And notice, baking a cake baking is not a productive function the way it is modeled here. The baking is a two-step process: measurements and heat, and they are two different functions. Okay. You put all these functions in different quadrants, and you see that this removing does not add any value, but it takes a lot of time. Do you agree? That you have a mold in which your cake is there, even though you had greased it earlier. Now, when you want to pull it out, it gives you a headache. Have you experienced this?
Yes, sir.
So this is the function that we want to improve upon. So what do? We say that, okay, okay. So it says two functions, this one and this one, baking and removing. These two functions can be trimmed. So first, because of the high cost and high functional significance, we look at, can this baking activity be given to some other function? So what are the other operations happening? Preparation. So when you're preparing, can you bake the same material simultaneously? No. Decoration, low cost, but also low value. Filling or transporting. If you want to trim the baking function, this is a very, very key function. You would want to allocate the function of heating and giving that time for baking to one of these other functions, preferably to a function in this quadrant, because you want to enhance the functional significance of all the functions in your system. So let us see what happens. We know that a supporting function can be trimmed if the operation required during the supporting function is trimmed, the supported operation is changed so that it does not require the support now, or the supported operation performs the supporting function itself, or the analyzed supporting function is transferred to the preceding or subsequent operation. We use the rule D. We say the heat, heating the cake in the oven, we would want to replace it by doing this, not by placing it in one place, but by during transportation. Have you seen such pizza stations, baking stations? Anyone who's not seen? If you have not seen, then I would say just go to a Domino's kitchen once, and you will see that there are such baking stations. So while the system is still moving, you're putting different toppings on it, and then the pizza gets formed, pizza gets prepared. So the second function that we identified for trimming was separate the cake from the mold. So an operation with a transport function can be trimmed there by using 4 rules, which we already discussed earlier also. What we are saying is that that we need to ensure that either the need to transport is eliminated or something is done so that this stress can be trimmed. We say that, okay, I will trim it by transferring the function to either a preceding or subsequent operation. How do we do this? I could have these kind of molds. Have you seen such molds?
Yes, sir.
What happens after the cake is baked? So you already grease the walls. You already would grease the base. After the baking has been done, you just open this clip. As the clip opens, the diameter. So you see there is an overlap. There's an overlap of metal there. As soon as the clip opens, the diameter of the mold increases, and you can immediately pull the cake which is sitting on this particular plate out of the system. Yeah. Any questions? So we've eliminated 2 functions. We've trimmed 2 functions in this cake baking example. Any function? Any questions?
Sir, in that 4 quadrant, in the 4 quadrants, sir, I feel that in fact decoration takes a lot of time and money. In baking, in fact.
Yeah. So again, you may use one particular formula, and you may say that, okay, in this quadrant, I want to put the decoration, the cost as high.
Yes, sir.
So then how do you trim decoration? For example, when I was talking about pizza, I said that you would put the toppings of the pizza while it is being transported, instead of putting it in a static place. So what happens if you loaded the decoration function onto a transport function? You loaded a supporting function, a providing function onto a transport function. Okay.
Yes.
Anything else? So would you want to play a game amongst teams? This game will prepare you for the solution finding things that we'll start to do from tomorrow.
Yes, sir.
So what is the game? Okay, let me show you. What we want to do now is we want to play a game called Force Fit. This is like a जैसे हमारा Bonvita quiz होता है, something like that. It is something like that. So what we do is, so the game is usually done between 10 to 12 people. We are more people over here, so we will not form only 2 groups. We will have more groups, and we can keep a scoreboard. So what is done is, we identify one problem, a big problem. Okay, which problem do you want to say? In the class, we had identified 2 or 3 very big problems. One was air pollution, the other was quality of education, and so on. Remember? That was where we started the CEC analysis. So let us say the big problem is air pollution, the smoke chamber that Delhi becomes, to clean the smoke chamber of Delhi in November-December timeframe. That is the problem that we have. So that problem statement is defined. And now your teams will give clues to the other team. Okay. The clues have to be far away from the problem. For example, I want to convert or clean the Delhi air during that smoke chamber period. And the clue that you could give is Chand pe Joon rengi thi. There was a small ant that was walking on the moon. And the team that is under test, they will spend 2 minutes to develop a realistic solution founded on this remote idea. So someone would now pick up this idea of an ant walking on the moon surface and say, what does this ant do, or whatever it does, how do I connect that to my problem and a solution to my problem? Okay. And we just do a round robin. The problem statement remains same. Just for example, we are 12 teams. So team 1 will give the hint to team 2. Team 2 will give the hint to team 3. So team 1 will give the hint to team 2. Team 2 will go into its breakout room and discuss for 2 minutes and then come out. Okay. समझ में आया?
Sir, can you repeat one more time?
Yeah. Actually, since we are 30 people, I do not want to go into 12 teams also, because what this means is that there are not sufficient students in every team also that are here today.
Yes, sir.
Right? So what do we do? अभी तो आपके ब्रेकआउट रूम करेंगे, टीम 1 टीम 2 से कोई भी नहीं अवेलेबल है आज क्लास में, तो मजा नहीं आएगा.
So we can like make random groups of 7 to 8 people, 4 teams, or maybe 3 teams of 10 members each. Randomly.
Yeah, that would mean that our earlier breakout room assignments would go for a toss. If I do recreate, just a minute, recreate all rooms. Okay, I can do this. Let me create only 2 rooms. So what we'll do is, so I'm making only 2 rooms now, just to keep it simple. So team 1 and team 2. Okay, there are only 2 rooms now. You will go to your room. You will identify a clue that is far away from the problem statement. The problem statement is clear. What is the problem statement we are talking about?
How to remove the smoke chamber of Delhi in the month of October.
Clean up the smoke chamber of Delhi. And a clue that is very distant from it. For example, there was an ant that was walking on the moon surface. Or someone would say that this pen is purple. Or someone would, or this pen is red. Or someone would say the ground is wet. Any clue has no obvious relation to a solution to the problem at hand. Okay. Now, as a group, you brainstorm, you talk to each other, and come up with ideas of how to connect the wet floor with the smoke chamber. For example, wet floor. Wet floor means that there was some rain that happened. Okay. If I can seed clouds and generate artificial rain, then that can be used to clean up the smoke chamber of Delhi. This is a viable solution to the problem.
Yes,
At least some idea. Cost kya hai, us sab ki baat nahi kare. At least it's an idea to clean up the Delhi air. Where did it come from? You saw the wet floor. Oh, wet floor, rain. Okay, artificial rain. Or there was this small ant that was crawling along the moon surface. You could say, okay, what moves around that causes pollution? Okay, cars and everything. But ant does not cause any pollution. So we say, okay, we reduce the number of cars on the roads on those days. We encourage people to walk. We encourage people to cycle. And that is, again, a possible solution for reducing the pollution load in that time. So effectiveness of a solution is not what we are calculating. What we are just looking at is that, are you able to come to a solution, a possible solution to the problem at hand? Okay. Ready? So once we go into our rooms, each team has 1 minute to identify a clue. Okay. Then all of us will come to the main room after 1 minute. 2 minutes kar dete hain. After 2 minutes, all of us come into the main room. Team 1 gives their clue to team 2. Team 2 goes back into their breakout room. Okay. Team 2 goes back into their breakout room. They work this clue out amongst themselves, and after 2 minutes, come back to the main room and give the solution. After they have given the solution, I am the jury. I decide whether the solution is valid or not. Team 2 gives the clue to the team 1. Then team 1 goes to their breakout room, they work out a solution, they come back and they give the solution. Is that okay? Clear?
Sir, whichever team is giving the clue, they should have like know the how to draw the
No.
line between clue to
No, no,
solution.
no, no, that is not your job. You give a clue
Okay.
जिसका आंसर आपसे निकल ही नहीं सकता. आपने निकाल लिया तो वो भी निकाल लेंगे. Do you think the other team is less intelligent than you?
Okay, okay. Yes, good.
आप अपनी तरफ से difficult clue देंगे. ठीक है?
ठीक.
Okay. I'm creating the breakout rooms there. Please go into your breakout rooms and think of a clue. Decide a clue. Rajat, Karanjot?
Like a very poor level. In that case, maybe I can use some good quality mask to at least protect myself at a personal level.
Where's the solution to air pollution?
Sir, also the thing is that this could be a mode of subsidizing. Let's say suppose I'm having an old phone, I want to buy the new iPhone, I'll give my old phone and get some discount back on that. So for subsidizing the EV, that is electric vehicles into the market, so that people who are having old cars and old vehicles that are running on petrol or diesel can give their old vehicles and get a new EV, something like that.
Okay, that is the second solution that you thought of. Hello. So आपका second solution थोड़ा सा palatable लग रहा है. That okay. You do offer exchange bonuses for the EV cars, just like exchange bonuses available for the iPhone, and that is how you reduce the cost of the EV car. That looks still palatable, but you did not spell it out in exactly that way. So I will give you 3 points out of 5. Okay. We'll play one more round and then the winner is decided, whether room 1 is the winner or room 2 is the winner. So room 1, give the next clue to room 2. Quickly. Or you want to go into breakout rooms?
Yes, sir. We haven't really decided on the two because.
Okay. So quickly go to the breakout rooms, only 1 minute. I will open the rooms and I will close them within a minute. Okay. So clue for room, so both the teams identify the next clue for your opposing team. Yes. So room 1, clue for room 2.
So the clue is my room door is not opening. Yeah.
Okay. So I'm opening the rooms, go back, room 2, quickly find the answer, solution. Okay. You got the clue?
Yes, sir.
Okay. You have 1 minute. So team 2, what is your answer? What is the solution that you propose? Team 2, the solution.
Just like when the door is not opening, we are locked inside the room. We are thinking of something like a something which we can trap inside the exhaust of a vehicular motor to collect all the pollution and convert it into something that doesn't release the pollution outside in the air, which will reduce the air pollution. So it will trap the smoke inside the car and convert it in and release it in some other way.
Okay, very interesting. Another 5 points to team 2. Great. So team 2 score is 10 as of now. Please give your clue to room 1.
So the dog is barking.
Okay. Team 1, the clue is clear?
Yes, sir.
Yes, sir.
So I'm opening the rooms. Okay. Team 1, what's the answer? What's your solution?
Yes, sir. So the clue was dog is barking, right? So we related that to some sort of an alarm system that would be put in our cars that will detect कि when our हमारे cars का like pollution level increase हो रहा है. So we can like maybe change it or like fix it so the air pollution that occurs from our cars is reduced.
Okay, so kind of particulate matter counter or meters that measures the
Yes, sir.
particulate
Yeah.
in your exhaust fan.
I
Yes, sir.
think so. It's similar to like the how we calculate air pollution around us, air quality index or something.
Okay.
But we can put a sensor or something.
Yeah, so I
So
can give you 5 points for this. So in these 2 rounds, room 2 appears to be the winner. Do you want to play one more round? अब room 2 कहेगा नहीं करना है, room 1 कहेगा करना है. Huh? You want to play one more round?
No, sir.
No. Okay.
No, sir.
Fine. So, but you got the experience of the game.
Yes, sir.
Yes, sir.
So what is important here is, or the intent of the game, giving you the game is that, see, when we will now tomorrow start to look towards solutions, you might get some tangential ideas or tangential thoughts or something. You just read an inventive principle and you say, okay, how do I connect it to the problem at hand? And this is something that you could do. You will need to stretch your brain. You'll need to brainstorm and say, how do I connect this inventive principle to a solution for my problem? Okay, so this force fit game can come in very, very handy when you're using inventive principles as a way of finding solutions. Okay, that is why I did this game today, so that we can move into, so in a way we are kind of starting to move into the solution phase with this game today. Okay, all the best, guys. See you tomorrow. And I will also release a review quiz, so that when we meet tomorrow, and you've done the review quiz, what happens is you get the hang of kind of cover up everything about problem identification phase, and then you enter into the solution finding phase. Okay, all the best.
Sir?
Yes.